Hello everyone, this is Down Inoch, Gianna, and Chiyang, and we'll be discussing Chapter 13, which is Architect for Low-Risk Releases. So in this chapter, we're focused on the challenge of migrating from the architecture we have to the architecture we need. So when you start a business, you might have an architecture that fits your business needs, but as you continue to grow, you'll need to redesign that architecture to allow for um, code to be deployed without high risk of breaking everything. So you need to split it up. And this is where we come into loosely coupled architecture. Loosely coupled architecture with well-defined interfaces that enforce how modules connect with each other. It promotes productivity and safety. It allows us to make isolated changes that don't affect the other areas of our application. So basically, this would be if you had tightly coupled architecture. Um, say a developer from another team could make a change in his portion of the code base, and it's actually going to affect yours because your code is so tightly connected to theirs that any change has the chance of affecting other areas of your code base. So we want to focus on loosely coupled architecture, put certain services and certain logic basically in a box and confine it there so outside changes have no effect. This is where we come to service-oriented architecture, and this is what allows small teams to work on these boxes, as I said, or smaller and simpler units of development, and these can be deployed independently, quickly, and safely. And this creates flexibility and scalability because, say, you need a new feature or something, you just get a new box, put that in there, and have that as a service. If they need your functionality or your data, just call your service, and you'll return that for them. And anything that they do on their end won't affect yours. Here we're going to discuss the monolithic versus microservices architectural archetypes. So, monolithic architecture is when all the code is in one place. You have one deployment. It's all just one giant application, all in the same spot. A microservice would be, as I said, the boxes analogy, where each box is a different microservice. And if you need that data or their services or logic, you just call their service and they'd return whatever you need back to you. So monolithic architectures, they're not inherently bad, and they're often the best choice for an organization early in the product life cycle because you don't have a lot of intertwined logic. Typically have like a small team. And so having everything in one spot just makes things a little easier. It's quicker to get things out in that stage of the development life cycle. But as you grow, you'll see that you'll start stepping on each other's toes a lot. You know, whenever you need to deploy, it can bring down it will bring down the whole application while you deploy, and you also run the risk of things changing things in one end of the application, breaking something on the opposite end of the application. That just increases as the logic grows and the teams grow and all of that. So by supporting evolutionary architectures, we can ensure that our architecture always serves the current needs of our organization. So this is just a list of the pros and cons. I won't read it all. I'll just kind of go over it a little bit. So you have the monolithic, which is everything in one. It's simple at first. It's a single code base. It's resource efficient, but coordination overhead increases as the teams grow. Has poor scaling. It's an all or nothing deploy with downtime failures. Long build times because it's all in one. It's not just one little service. Then you have the monolithic version 2. This is it's like the monolithic but split up into front end, back end, and database layer. So this is a little more broken up than the version 1, but you still run into the issues of poor scaling and redundancy. It's difficult to tune properly, and it has an all or nothing schema management. But it does offer a little bit of pros as well, as in simple at first, still resource efficient. It's a single schema, so that is easier to manage at first, but as technology changes, that could be difficult. Then you have your microservice, which is everything is independent in their own isolated box. So it keeps each unit simple, independent scaling performance dependent on that single service, and you can deploy this very easily, and it won't cause downtime for the entire application. The cons would be there's a lot of moving parts, a lot of cooperating units, a lot of repositories, and it requires specific tooling for that, such as build tools and version control. Things like that are much more dependent or much more utilized in a microservice type application. So in order to get to this microservice, whenever we start growing from this monolithic, we can use the strangler application pattern. And this is whenever you put existing functionality behind an API and avoid making further changes to it. So once we decide we want to change this certain functionality, you just turn it into an API. And so whenever someone needs that functionality, they can just call the API and get whatever they need back from it, but it will no longer change. All new functionality will be implemented into a new service that uses the new desired architecture, and then only calling the old system whenever you need changes that aren't in the new functionality. So in conclusion, we need to safely migrate from one architecture to another. We talked about the strangler method for that. We have to reverse the downward spiral, which would be, building these monolithic applications and just continuing them to grow and morph even as our business grows. That leads to terrible consequences where deployments just drop off in frequency, and the code is not as safe, and it's just a whole mess. So by stopping that and by using the Strangler application, we can stop this downward spiral and get our microservice architecture up and running and have safer, low-risk deploys.